When David talked about how much data qualifies as big data, he went through an example of how we can potentially analyze a big file by dividing it into smaller pieces, sending the chunks to our colleagues, running the processing in parallel, and then collecting the results. This workflow resembles the MapReduce logic quite closely. Although Spark provides higher-level abstractions and in-memory computation, it's useful to know a bit more about the idea that inspired it. Let's use MapReduce on a 4-node cluster to calculate how many times each song was played in the last year in our music streaming service. Since our company has grown quite a lot, the log data containing all these events is hundreds of gigs and cannot be processed on a single machine. In a MapReduce job, we have 3 well-defined steps: map, shuffle, and reduce. Let's assume that we stored our big log file on HDFS. First, we need to break the data up into smaller chunks so commodity machines can handle the computational load. Fortunately, HDFS will take care of this for us. Let's call these chunks partitions. In the first step, each map process reads a partition from disk, transforms each record in that given partition, then writes these modified records to an intermediate file. The transformation in this case consists of 5 steps. We read each line of the log file, check if it's an event describing a user listening to a song, then we check that the timestamp is in the correct range, then extract the name of the song, and finally create a tuple with the name and the number 1. At the end of the step, we will have multiple intermediate files containing pairs of a song title and the number 1. These type of pairs show up a lot in big data and are called key-value pairs or tuples. Even with 4 machines, the data is so large, we will need many map processes, one after another, to munch through all the records we have. Once all the map processes are complete, the second step is the shuffle. All the records from these intermediate files are shuffled across the cluster, so the pairs with the same song, the key of the key-value pair, end up on the same machine. This way, when the node aggregates the values for a key, it can be sure that it has all the corresponding data for a song and can compute the correct final result. In the last, reduce step, the values for a given key can be combined. In this case, we just need to sum all the ones for a given key. Finally, the count results are written to the output files.